Welcome to this lecture on process control, chapter 3, first order systems, part 8 of the chapter 3. So in this, I'm going to solve a numerical problem related to the response of first order systems. The problem is this: a thermometer with a time constant of 20 seconds is at a steady state temperature of 30 degrees Celsius. At time t equal to 0, it is placed in a temperature bath maintained at 90 degrees centigrade. So you have to determine two things. One is thermometer reading at t equal to 30 seconds after the disturbance. And second one, what will be the time required for the thermometer to read 85 degrees centigrade. Right. So thermometer is a first order system. This is the dynamics of first order system. Though not mentioned here, it is understood thermometer as a first order dynamics. So this is a transfer function of thermometer k by tau s plus 1, and we know for thermometer the gain is k is 1, and it is given that the time constant tau is 20 seconds. Well, initially the thermometer is at steady state temperature of 30 degrees centigrade. We don't know where it is at 30 degrees centigrade, maybe in a room or in a liquid bath, wherever it is. So let us assume that initially thermometer is at steady state in a room. Initially the thermometer is at a it is at a room here, where the surrounding temperature is at 30 degrees centigrade. So thermometer has been here in the room for a long time, so that steady state is reached. So the surrounding temperature of thermometer, as per our notation, Xs at steady state is 30 degrees centigrade. And since the thermometer is at steady state, the reading shown by the thermometer, the output of the thermometer, Ys at steady state, will also be equal to 30 degrees centigrade. So this Ys also will be equal to 30. So this is the initial steady state. This is the initial steady state. Initial steady state. And we also have a liquid bath here. Which is at 90 degrees centigrade. We have a liquid bath at 90 degrees centigrade. Now what happens here at t equal to 0? This thermometer is suddenly placed in the liquid bath. At t equal to 0, this thermometer is suddenly placed in the bath. At t equal to 0, this thermometer which was outside is suddenly placed in this temperature bath. Now the liquid bath is temperature of 90 degrees centigrade. Bath is at 90 degrees centigrade. At t equal to, I repeat, at t equal to 0, the thermometer which was outside at a temperature of 30 degrees centigrade is suddenly placed in the liquid bath at 90 degrees centigrade. Now as a result, the thermometer reading Y is going to change. This bath temperature will be constant 90 degrees, but the thermometer reading Y will be changing. Now what has happened? What type of input is given to the surrounding of the thermometer? The temperature of the surrounding of the thermometer changes suddenly from 30 to 90. It changes from 30 to 90 degrees. So step in from 30 to 90 degrees. So we plot X, which is surrounding temperature, it suddenly changes from at t equal to 0, it changes from 30 to 90. So it's a step input. So if you plot in terms of capital X, and before that at steady state, At steady state, what was the temperature, surrounding temperature of thermometer? Xs. And that will also be equal to the steady state output reading of the thermometer. At steady state, Xs and Ys will be equal. That how much was that? 30 degrees centigrade. That is before change. That is T less than 0 before change. Xs equal to Ys equal to 30 degrees. Now, so this is a step input, right? Now, if you write in terms of deviation variable, capital X is what? X minus Xs. So this is temperature, surrounding temperature of the thermometer changes quickly or instantaneously from 30 to 90. It is a step input. It's a step input, right? So if you plot this in terms of capital X, what will be this? This will be X minus Xs. X minus Xs is X minus 30. So if you plot in terms of capital X, this will be 0, right? Here it will be 0 and here it will be 90 minus 30 is 60. Right? Here it will be 60 and here it will be 0. So let me plot that again. So if you plot this in terms of deviation variable, X versus capital X versus T, what will be this? This will be 0 and this is going to be 60. In terms of small x, this will be 30 and 90. In terms of capital X, it will be 0 and 60. In terms of deviation variable. In terms of small x, the actual variable, it varies from 30 to 90. In terms of the deviation variable capital X, it varies from 0 to 60. So this is a step input of magnitude. How much? So input is, how do you write the step input? Step input is m into ut. Where how much is m? This is m. The magnitude is m. Okay. This magnitude is m. So m is 60 degrees. Now what is the response of this? This is step input, first order system. What is the response? Step input, first order system. What is the response? The response equation which we have derived earlier in previous classes is y of t equal to mk into 1 minus e power minus t by tau. So we have to simplify this. So if you simplify this, let me substitute here. This is capital Y means y minus ys. Remember, y is the thermometer reading, output of the thermometer reading, equal to this same mk, or I can substitute for mk and all that. Okay, same 1 minus e power minus t by tau. So if I substitute for each values, ys is how much? 30 degrees. M, magnitude of step is 60. Here 60. Magnitude of m is 60 here. 60. K is 1 for thermometer. 1 minus e power minus t by tau, how much? 20 seconds. So this is a response equation. So if we further simplify this, y equal to 30 plus 60 into 1 minus now what is the question? There are two questions. One is, what is the thermometer reading at t equal to 30 seconds? At t equal to 30 seconds. Question number, this is the response equation, right? So at question number 1 is, at t equal to 30 seconds, what will be y? So you substitute here, y equal to 30 plus 60 into 1 minus e power minus 30 by 20. So if you solve this, the answer is 76.6 Celsius. So this is the answer. At t, this is the answer for first question. At t equal to 30 seconds, what will be the thermometer reading? Why, remember, why is the thermometer reading? That is going to be 76.6 degrees Celsius. Right. Now the second question is, what will be the time taken for the thermometer to read 85 degrees centigrade? If y were to be 85 degrees centigrade, what time it occurs? So that is the next question. Second question, the time needed for the thermometer to read 85 degrees Celsius. So thermometer reading y 85 centigrade means what is the, at what time it occurs. So same, so go back to this equation and substitute y equal to 85 and find out what is time. That's all. So substitute y equal to 85. So 85 equal to, I am substituting the response equation, that is here, same equation. 85 equal to 30 plus 60 into 1 minus e power minus t by 20. 85 equal to 30 plus, I substituted in this equation here, 61 this. So if you solve this, you're going to get, solving this, solve for t, you're going to get t equal to how much? 49.7 second. So first question is, what will be the thermometer reading at 30 degrees centigrade? The answer is, at 30 degrees centigrade, the thermometer will read 76.6. That is, after 30 seconds after you put the thermometer in the liquid bath, the thermometer reading is going to be 76.6 only, and not the bath temperature, which is 90. Bath temperature is 90, but the thermometer shows 76.6 only at 30 seconds. The next question, how long it will take for the thermometer to read 85 degrees centigrade? It will take 49.7 seconds after the disturbance is given to read 85 degrees Celsius. So this is about giving a step input to your first order system. In this case, example is thermometer, and finding out the numerical values of the dynamic response. I hope it is understood, it is clear. We'll come with more examples in the subsequent classes. See you.